Good evening, students. See, today we have taken the topic of grade 11 organic chemistry, homologous series. So, I just want to inform you one thing. So, I have taken one column here because we are getting the reflection of the light. So, I tried so many methods but couldn't avoid. So, I don't use this portion of the board. So, please try to understand that. Now, see, if you talk about a homologous series, as we are aware of this, series is nothing but, because we are talking about organic chemistry, it deals with the carbon compounds. I can write like this: carbon 1, then 2 carbons, 3, 4, 5, 6, and so on. So first part, that is what is meant by series here, we are increasing the number of carbons here. And second one, homo, what does the word homo indicates? We have two things. First one is homo and second one is hetero. Homo always indicates a similar type of things. It can be, for example, same number of or same type of functional groups. Hetero indicates a different type of functional groups, like that. So always keep in mind. Suppose I'll write a homolysis. Lysis means breakage. Homolysis, equal breaking. Heterolysis, unequal breaking. Now, suppose you are having a difference of, same difference of CH2 group, that is homologous, same. Suppose the difference is not the same, then you can say that hetero. So one thing keep in mind, homo always indicates similar, hetero indicates dissimilar. So now in this aspect, we are talking about homologous series. It indicates that the number of carbon keep on increasing and they have something similar. I don't want to reveal that what is that similarity. Later on we will see that that similarity is a CH2 group, and always CH2 group in chemistry is known as a methylene group. So this is about the introduction of homologous series. Now, what are the functional groups present? So next, functional groups. Functional groups. Homologous series, you can take any functional group. But before entering into that, what do you mean by a functional group? See, always you will write down as alcohol, OH, aldehyde, CHO, COOH, carboxylic acid, like that. But no one will tell you what is the definition of a functional group. Now let me show you. An atom or group of atoms responsible for physical and chemical properties of that compound. One by one I'll split it up. Now an atom. Let us take the example. If you are taking atom, I will write X. What is X here? X is halogen. You can take it as fluorine, chlorine, bromine or iodine. And once again, smallest size, maximum reactivity, avoid fluorine, iodine. Largest size, least reactivity, this also you avoid. So whenever you are writing X, take it as chlorine or bromine. In this condition, we can say that you are having an atom. So atom here we can take either chlorine, bromine. Next one is group of atoms. Second one, group of atoms. So you can take anything. I'll take OH, nothing but alcohol. It's a group in the sense one oxygen, one hydrogen is there. Next, I'll take aldehyde CHO. Let me expand and write like this. C double bond OH. So nothing but aldehyde. Then ketone. See, both are carbonyl compounds with a CO group, but later we will see what is the difference. But as of now I am writing the second one, that is group of atoms. Here also you are having carbon and oxygen. We can write it as ketone. Next, carboxylic acid. COOH group known as carboxylic acid. So one thing is clear, what is that? First I have taken an atom, this is the example. And second one, I have taken group of atoms here. These are the example. Now they are responsible for either physical or chemical properties of that compound. So how can you prove that? How can you prove that? Now let me take 1, 2, 3, 4 carbons. You know, if 4 carbons are there, the root word is but. So let me take one more 4. 1, 2, 3, 4. Same way another 4. So in all these conditions, if you take, what will be the root word? Everywhere you have to use but. Single bond between the carbon, you know that ANE alkane. So we have to write a butane. Second one is also butane. Third one is also butane. Fourth one is also butane. Fine. So this is nothing but nomenclature, which is responsible for physical and chemical properties, and also we can say that it also depends. What is that? The nomenclature of that compound. Let me write down. First, a single atom. I'll take chlorine, an atom. Now what will be the name of this compound? Earlier it was butane. Now it will become chlorobutane. Second one, we will take OH. Let me write OH. Now what will happen to this 4 carbons? So definitely butane, and we will write OL. So it was chloro, here it is OL. Because you already know the nomenclature, I am just explaining you how to define functional group by writing the either atoms or group of atoms. So OH, butanol. But if you are considering number of carbon, it should be butane. But now the difference is chlorobutane and now butanol. Take aldehyde. So C double bond O dash H, aldehyde. Now it will become butane Al because it is aldehyde, and COOH, carboxylic acid. Now it will become butanoic acid. So once again I'll explain you. 4 carbons are there. So accordingly butane. But because of these functional groups, which functional groups? Either atom like chlorine, or you can also write a bromine. What happened here? The name changed. Instead of butane, you have to write chlorobutane. And now chemical properties and physical properties of this will change, because chlorine is present in that. It shows the chemical properties related to halogens. And now OH is there, nothing but second one group of atoms. Due to that, the name changed as butanol. Next, aldehyde is there, so it became butane Al, butanol. Then comes butanoic acid. So what I want to say is, a functional group is an atom or group of atoms which is responsible for the physical chemical properties and nomenclature of that compound. So that is why all these are known as functional groups. Hope you have understood this. Next, how to write the homologous series for the various functional groups. See, from there itself you can take. Mainly before you start, we can take alkane, alkene and alkyne. See, these are the hydrocarbons. So single bond, double bond and triple bond. You know the general formula, CnH2n plus 2. Now remove 2. What you will get? CnH2n. So I have subtracted 2. And from here again subtracted 2. What you will get? CnH2n minus 2. So I have got the general formula also. Now what is the first rule? Write the series here. How to write? Carbon 1, 2, 3, 4 and 5. Let me write 5. Now here what is the value of n? N is equal to 1. You can easily see, no? Cn, I have written C1. Substitute the other hydrogens and write it as H 2 into 1 plus 2. Nothing but CH 2 plus 2 4. CH4. You know it is methane. Next, the same way you substitute N is equal to 2. So here you will get 2 into 2 plus 2, that is equal to C2H6 ethane. Next, C3 you will calculate and get H8, C4 H10, C5 H12. Like this I have written the series. Next, what is the difference between these two successive members? So let me write the difference between these two members, like these two. What will be the difference between the successive members of the group? C2H6 minus CH4. So 2 minus 1 is 1, 6 minus 4 is 2. That means the difference between the successive members here is a methylene group, CH2. Same way, next, what are the next two groups? Here I can write it as the difference is CH2. Next, between these two, C3H8 minus C2H6. 3 minus 2, 1. 8 minus 6 again 2. Again, the difference between the successive members is CH2 methylene group. Now come to these two. What is the difference? If you subtract, easily you know, you can identify that. Once again you will get CH2, nothing but a methylene group. So here we can write it as CH2. So what I can write finally? I can write that if you take alkane with the general formula CnH2n plus 2, first 5 members, or you can say first 5 compounds, then what will happen? The difference between the successive members is same. So therefore, can I say it is homologous? According to our discussion, we said that homo means something is same. Here, the difference between the successive members is same, which is CH2 group and methylene group. So hope you have understood this. Similarly, see, this holds good for the next two hydrocarbons, CnH2n. Here one important aspect is that N can never be 1. Here also N can never be 1. So what is the reason? I cannot write like C double bond H. We cannot write C triple bond H. So N can never be equal to 1 in case of alkenes and alkynes, because the hydrogen here has valency of only 1. Here also the valency of hydrogen should be 1, but here it shows 3 and here it shows 2, which is never possible. Therefore, the N value now will start from 2. Substitute and get the formula for this C2H 2 into 2, that is 4. C3H6, C4 H8, C5 H10, C6 H12. So like this you can take. So N value can be 3, Here n is equal to 4, 5, 6 and so on, anything you can take. Now because you have written this, so this is ethene, ene, then propene, propene, butene, like this. Once again apply the same thing. What is the homologous series? We have written the carbons in the increasing order of their number. Check out if the difference between successive members is same or not. C3H6 minus C2H4. 3 minus 2, 1. 6 minus 4 is 2. Once again you got methylene group. So the difference between these two is CH2. Next, find out the difference between these two. C4H8 and C3H6. 4 minus 3, 1. 8 minus 6, 2. Once again CH2. So here also we can find that the difference is CH2 methylene group. The difference between the successive members in this is always CH2, nothing but homologous. So same difference, a series, homologous series, and the functional group is alkene, which is a double bond. Hope you have understood the second one. Now coming to the triple bond, that is alkyne. So I already told you n cannot be 1. Now let us take n is equal to 2. Apply the general formula. What you will get? CnH2n minus 2. So here if n is equal to 2, C2H, 2 into 2, 4, 4 minus 2 is 2, C2H2. N is equal to 3, C3H. So here 6 minus 2, 4. N is equal to 4. So 2 into 4, 8. 8 minus 2, that is 6. N is equal to 5. So 2 into 5, 10 minus 2, 8. Last one you can take, see, so you can continue also. N is equal to 6, C6H. 2 into 6, 12 minus 2, 10. So this is about the series of alkyne. Series of alkyne. Now find the difference between the successive members. C3H4 minus C2H2. 3 minus 2, 1. 4 minus 2, 2. So easily you can identify the difference between this is a methylene group. Next, between these two. C4H6 minus C3H4. 4 minus 3, 1. 6 minus 4 is 2. So again I can easily understand the difference between the next two successive members is also methylene group. So homologous. Same way if you take the difference between this and the difference between this, you can identify that you will get methylene group. Same group you are getting. The difference between successive members is same group. That is nothing but homologous series. So hope you have understood the first three functional groups. See, writing the other functional group also is very easy. I will tell you how. So hope you have understood this. First, let us take for halogen, then we can take the remaining functional groups also. To write this, before you write this, you need to know what is meant by alkyl group, that is R. So what is meant by alkyl group? If you know that, easily you can put the functional group to the alkyl group. Now, alkane minus 1 hydrogen is nothing but alkyl group. What is alkane? Just now you have seen methane, C2H6 ethane, C3H8. Propane, minus 1 hydrogen gives you CH3. Here minus 1 hydrogen gives C2H5. Minus 1 hydrogen gives C3H7 and so on. You can also write, if you want to put next one, C4H10 minus H gives you C4H9, C5H12. See, you know very easily, no? Alkane you have written CnH2n plus 2, general formula you yourself calculated and you got this. I'll tell you next one, minus 1 hydrogen gives you, that is C5 and H11. Next, methane. Meth means 1 carbon, you know. Ethane, it means 2 carbons. Propane, prop means 3. Butane, 4. Pentane represents 5 carbons. After this, very simple. This is alkane, we wrote alkane names. Here it is alkyl, you will write the same alkyl groups. Methane now is written as methyl. Ethane, ethyl. Propane, propyl. Butane, butyl. Pentane, pentyl. Keep this in mind. Now we will go to the other side and write down the homologous series for any functional group with this idea. So first you want to take, so let us take chlorine. For halogens, how to write the homologous series using this. Now I am writing for chlorine or Cl. How to write the homologous series? Just take R dash Cl, that's it. You want to write, suppose for alcohol, that is OH, you will simply write R dash OH. That's it. So what is R? You know R is alkyl groups, these groups. So let me write this first and foremost thing. CH3 dash Cl, next C2H5Cl, C3H7Cl, C4H9Cl, C5H11Cl. That's it. So this is the homologous series with the functional group chlorine. You can also write bromine, whatever. So how to check it? Now the difference between the successive compounds will be CH2. Here also the difference, if you check, that will be CH2. Here also the difference, you check, it will be CH2. And here also the difference will be CH2. Homologous. The difference is methylene group and the same functional group is also there. So R dash functional group will be the method to write homologous series. Next, you want to write for alcohol, same thing, R dash OH. Take CH3 OH, C2H5 OH, C3H7 OH, C4H9 OH, C5H11 OH. So you can try also, you can check the difference and you will get CH2. Here difference is CH2, here difference is CH2, and here also the difference is CH2. So like this you can write the homologous series for halogens and alcohol. Only one small point I have to mention. Here in your functional group there is no carbon. Suppose if in your functional group a carbon is already present, then what you should do? So let me take that examples also. So hope you have understood R group. So I'll write here So what are the functional groups in which carbon is already there? See, you know aldehyde. So I'll write R dash CHO is there, number 1, and R dash C double bond O dash R. Right? So one more is there, carboxylic acid, that also I'll tell you. So this is nothing but aldehyde, and this is nothing but ketone. Both are known as carbonyl compounds. Carbonyl compounds, C double bond O, this group is there, that are known as carbonyl compounds. Now, already one carbon is there. Therefore, what we have to do is start with hydrogen like this, H dash CHO. This is your first compound. Because in the homologous series, you know, one carbon we have to start, that is already there. So instead of RCHO, start first with H, then put R. Hope I am able to make you understand. Already carbon is there, so write H first. After this, you can start with CH3CHO methyl as usual like that. C2H5 CHO, C3H7 CHO, C4H9 CHO. See 1, 2, 3, 4, 5. That is enough. If you want to go beyond that, you write C5H11. So what I am trying to tell you is, because your functional group is already containing carbon, you start with hydrogen, then R group as usual you can follow. Come to this, a ketone. Here one carbon, here another carbon. So the first member is itself is like this. This is the first member in the ketones. How many are there? 1, 2, 3. So definitely you have to add 1, 1. Let us take from the other side. You keep on adding. This is methyl group. Let us take. And next, go with C2H5. So R group. CH3, C double bond O dash. So R group in that first methyl we wrote here. Second ethyl we wrote here. Third propyl, C3H7 we have written. Like this you can keep on going. So what I mean to say is, keep one as constant. CH3, let us take, you put a CH3 constant. This whole thing keep constant for ketone, and keep on changing the R group here. So CH3CO group is constant. Next, what is the next compound? CH3CO, C4H9, then CH3CO, C5H11. So hope you have understood this. So this is about halogen, alcohol, aldehyde and ketone I have written. One last one, that is carboxylic acid. So let me complete that. In the case of carboxylic acid, you know that functional group is COOH. R dash COOH will be there. So already carbon is there. So we cannot write like this. Therefore first compound is HCOOH. After that you start this. One carbon is there. Next, CH3 COOH. First methyl group. Next, C2H5 you write. To that add COOH. Next compound, C3H7 propyl group, and add COOH. So we have 1, 2, 3, 4 compounds. Add the one more C4H9 and COOH. So using this method we can write up to this 5 compounds we have written. So the homologous series for carboxylic acid. So very simple. If at all there is already carbon, then what we do? We start with H, first compound. later you can start with the same R group. So this is the little information about how to write a homologous series. So this is there in grade 10 as well as in grade 11 also. So organic chemistry without homologous series, so we don't generally get any questions in your exams. Hope you have understood this. Thank you so much.